Today's lesson is acids and bases. So we're going to look at what acids and bases are. We're going to take a look at how things can react to create acids and bases and what types of reactions can take place with an acid and base. We'll also start by just becoming a little bit familiar with what an acid is and what a base is. So an acid. An acid is a substance that produces hydrogen ions when it dissolves in water. So when you take something that's an acid, let's use an example, hydrochloric acid. When we're working with hydrochloric acid, when we put this substance into water, what ends up happening is the hydrogen and the chlorine split. We know that this is a molecular compound. It exists with a bond between the two elements that are present. But when you put it in the water, there's enough interaction between the water molecules to actually overcome this bond. And what ends up happening is that the atom that wants the electron more, which in this case is the chlorine, will take the electron pair with it when it goes into the water, and it becomes a chloride ion, a Cl- ion. So when we place it into water, that's actually what's occurring. So when we talk about something releasing H+ when dissolved in water, that has to be considered an acid. Acids are typically sour tasting. Okay, that's one way to recognize when you have an acid present is to taste it. Never do that in a chemistry lab though, but that's one of the common properties. Okay, sour taste. The other thing that's common with these things is that they're good conductors of electricity. So because this will dissociate or break into H+ and Cl-, those are charged particles. And when the charged particles are in water, they can move around. And that allows a transfer of electrons to take place. Very important piece for acids. There's other acids that we could look at. Other acids that we could talk about might be, another example of an acid would be sulfuric acid. So sulfuric acid has the formula H2SO4. And this one, when we take a look at sulfuric acid, if we take this thing and we have our H2SO4, we can put it in water, which makes it aqueous. And what that really does is it breaks it apart into its hydrogen ion and its SO4 2- ion. But when we're considering an equation, we have to look at that this sulfuric acid will actually release 2 hydrogen ions. So every time we put sulfuric acid into water, each molecule of sulfuric acid will give up 2 H+ ions. Whereas the hydrochloric acid, if we go back to the hydrochloric acid example, if we take hydrochloric acid and we put it in water and make it aqueous, okay, we get our H+ and our Cl- formed. Okay, so we get these ions released. And it's the H+ ion that we're really concerned about. So this is the major piece. This is the major piece. That's what tells us an acid is present. So when you see those, we should recognize that that gives us an acid. A base. Some people will talk about these as alkaline or alkali. When you look at a base, in water, when you put a base into water, we get dissociation occurring again. So this thing will break into ions. When it breaks into ions, though, we're not releasing an H+, we're actually releasing an OH-, a hydroxide. So these things release OH- ions, which is your hydroxide. An example that we can look at, sodium hydroxide. So if you remember sodium hydroxide, it has the formula NaOH. So when we take a look at this, if you put it in water, so we take our sodium hydroxide and we put it into water and make a solution out of it, we actually get sodium ions, so Na plus dissociates, and we'll also have our OH minus present. So we will always see with our bases that OH minus present. Some substances don't have an OH directly in their formula, like sodium hydroxide. It's got the OH right in the formula. There are some bases that you come across that don't have it in the formula, but they still behave as a base. The hydroxide gets formed in a different way, and you'll focus on that more in grade 11 and 12 chemistry. So another example of a base would be ammonia. Okay. Ammonia NH3 is another example of a base, but it doesn't really follow this general trend of having hydroxide in it. Okay. It's a base, but it doesn't follow that trend. So bases can sometimes be funny that way. For our purposes, what we're going to focus on in grade 10, though, we'll be looking at bases that have hydroxide in them. So you'll see hydroxide in the name, and you'll recognize that when you put this thing in water, it dissociates, releasing an OH minus particle. Now, bases are also good at conducting electricity. So some properties for these guys. They're good conductors as well because they, again, have free moving ions, and ions are charged particles, and electricity deals with charged particles. So they're excellent conductors. We also find them to be bitter tasting. So that's a property of these things, bitter tasting. And one other thing that we commonly notice with bases is that they're slippery. Okay, so if you touch them, they're slippery. Some people say that this is because the sodium hydroxide, when it touches your skin, it starts to break down the skin molecules, and that's what gives the slippery feeling. But it's definitely a common property with bases. So if we take a look at an example here. Here we've got an acid. So let's say we have hydrochloric acid, our H plus and our Cl minus. So we've got a couple molecules of these. And notice they're bonded together. We see these two atoms stuck to each other, right? Representing that they're bonded. When we put them into water, which is kind of our divider in the middle, we'll see that it releases H plus. They separate. They no longer are bonded together. We get separate individual ions present. So we get our H plus ions and our Cl minus ions. And it's the H plus that we're looking for. Seeing that H plus gives us an acidic solution. So that's how we get our acidic solution. Bases, on the other hand, when you look at a base, you're going to see something that has OH minus in it. So we can use something like lithium hydroxide. We take lithium hydroxide and drop it into water. We've got our Li plus, our OH minus bonded together, right? We've got this beautiful ionic compound. We drop it into water and it dissociates. So when it dissolves, it dissociates. It breaks into its ions. Okay? And we get our lithium plus ions separated from our hydroxide ions. And seeing the hydroxide ions present in solution is what gives us that basic solution. I'm writing a word at the top here, dissociation. Dissociation is what's occurring when these things split into ions when you put them in water. Okay? So you see them bonded together, drop it in water, dissociation occurs. It splits into its ions. So that's a key word there you might want to remember.